Okay, hi, welcome to my humble video. This is a solutions little video that goes with the expressions little assessment, practice assessment that we're going to do. And remember, all this work with expressions of combining like terms, using distributive property, factoring are going to be the nuts and bolts that we'll need in order to solve equations. So with that in mind, let's get this frog out of the way and let's look at the first problem. Evaluate the expression for k equals 11, m equals 6, and n equals 3. So in evaluate, they often want you to, when they give you values, you got to plug them in, and you simplify whatever expression you have. So in this case, it would look something like this. I'm going to put 11 plus 13, so I plugged in for k. I swapped out 11 for k, and I have to divide that, because it's a fractions division problem, 2 times whatever n is. N's 3. So when I simplify this, 11 plus 13 is 24. 2 times 3 is 6, and 24 divided by 6 is 4. That was straightforward enough. Let's try number 2. Evaluate the expression for k equals 11, m equals 6, and n equals 3. And we have a different expression now. So I'm going to plug in my 6 into m. And I'm going to get something that looks like 6 plus 2, quantity 6 plus 2 squared. I work on the parentheses first. 8 squared, and 8 squared means 8 times 8, or 64. Okay, that seems straightforward. Okay. Number 3 asks, which property is demonstrated by the following? So I have negative 2 times the quantity 5x minus 9, and that's equal to negative 2 times 5x minus 2 times negative 9. That's one way to read this. But what I notice is that I've got this negative 2 here, and I'm multiplying it by each term that's on the inside here. So there's my negative 2, there's my negative 2. I'm multiplying by each term. This is a demonstration of the distributive property. So which property is used? Well, the distributive property. And the distributive property is going to be key in a lot of situations. So there's the first 3 problems. Here it says, number 4 says, use the distributive property to evaluate the expression. So I want to make sure that I actually use, because that's what my instructions tell me to do. And so I have 2 things being multiplied here. I have this being quantity being multiplied by that. So with the distributive property, I have to multiply what's outside the set of parentheses by everything on the inside. So I'm going to multiply that times this piece. I'm going to multiply that times this piece. So when I do that, I'm going to have something that looks like this. Negative 6 times 11. And then in addition, I'm going to have negative 6 times negative 7. I need to combine those 2 things. So literally, I'm adding these 2 little multiplication problems. So negative 6 times 11 is negative 66, and I'm going to combine that with negative 6 times negative 7, which is going to be positive 42, and negative 6 plus 42 is going to be negative 24. Okay, so let's make sure I clear that. When I'm combining, I'm adding 2 integers and their opposites. I can simply subtract them. So same sign, add them up. Different sign, subtract. So what's 66 minus 42? Well, that is 24. And then I take the sign of the higher number. The ones, this is further from 0, so I've got more negative. So the answer has to be, my answer is going to be negative 24. This little subtraction problem is 24, but the answer to this is going to be negative 24. And just as a double check, if we were simply to use order of operations instead of distributive property, what would this look like? It would look like 11 minus 7 would be 4, and 4 times negative 6 is negative 24. So I do get the same answer when I use order of operations. So order of operations, distributive property. Next, use the distributive property to rewrite the expression. Simplify completely. So it looks like now I've got a variable in there. So I'm going to multiply what's on the outside, 7, times everything on the inside. So 7 times 9x minus 7 times negative 7. Oh, I take that back. I wrote that wrong. This minus sign is that, so this would actually be 7 times 7. So this 7, got to be careful here. This 7 is this 7, where this I simply brought straight down here. So I have 7 times 9x is 63x minus 7 times 7 is 49. Of course, you could rewrite it the other way. I could do 9x times 7 minus 7 times 7 to be the same thing again. Either way, 63x minus 49. Notice here that the way this is laid out, you could take advantage of this this formatting here to even answer the previous problem up here. Because I'm using the same property. I'm just here I've got numbers, here I've got a variable added. Okay. Number 6. Find the perimeter of the rectangle. Well, I know that opposite sides are the same, so I know this side is the same. And I know that this side over here is the same. So if this side is x plus x minus 2, this side over here must be x minus 2. And so the perimeter is the distance all the way around. So I'm going to have one long addition problem. Plus 5 plus x minus 2. And so now I'm combining like terms. So let me deal with my variables first. So I have, there's an x, there's an x, there's an x term, and here's an x term. Notice I'm highlighting this sign because I can think of it as just one big addition problem that way. So 3x and 1x is 4x, 7x, 8x. So I have 8x, where if I was to highlight my constants, I have a positive 5, a negative 2, positive 5, and a negative 2. So if I was to write those down, so I'm going to have a plus 5, and then a plus a negative 2. So these two, it's a plus a negative 2, right? Because subtraction's adding opposites. Plus 5 plus negative 2. That's just being able to see that even though it says subtractions minus 2, I can think of it as adding negative 2 because subtraction's adding opposites. But 5 plus a negative 2 is 3. So that's worth 3. And it's the same thing, so that's worth 3. 3 plus 3 is 6. So my final answer is going to look like what? It's going to look like 8x plus 6. That's as far as it can go. I can't combine 8x and the 6 because I have a variable there. You can't add variables with constants. Okay, here's a similar problem. It just starts out differently. Simplify the expression. So again, I'm going to look at all my terms with the variable, and I'm going to highlight the sign in front of it. So when I do, I have like a negative 5g, a positive 11g, and a negative g, a negative 1g. So these three things together, I have an 11g, and I have a negative 5g, and a negative g. So I can think of it as 11 minus 5 is 6. 6 minus 1 is 5. So together, that is 5g. And in my constants, I have an 8, I have a negative 13, I have a negative 7. So if I was to write those down, I'll do my constants in a different color. How about that? So I have a positive 8, I have a negative 13, that's one way to see it, and I have a negative 7. Well, these two together are going to be negative 20, and negative 20 plus 8 is going to give me negative 12. So I can write it like this, because this is the same thing as saying 5g plus negative 12. This would be the more proper way to write it, because you want to avoid having plus a negative. I'm going to stop this here. We'll pick it up again in a moment.